Okay, what is epsilon and what is minimum points? Is that clear? Yes, Pavandeep, can you tell me what is this?
Good morning, ma'am.
Good morning, beta. Yes, beta, can you tell me?
Ma'am, epsilon is the length of the radius and it can detect the neighborhood around a particular data point.
Like you can say that suppose if you are having an data point over here, then all other data points that are coming within this distance epsilon, okay, that is just for reference that we are actually making a radius. So actually what's the meaning of epsilon? That you are finding all other data points that are neighbors to this data point. Now how can you find out what are the other data points that are neighbor to this one? For that we need to find out the distance between this and all other data points. So if the distance between this and all other data points that is lesser than equal to epsilon, then you can say those are the neighbors. But if any data point is having the distance more than epsilon, then that is not the neighbor. Okay, so epsilon is for that. Okay, Pavandeep, what is minimum points?
Ma'am, can you please repeat?
Mean points, this one, second parameter, what it stands for?
Ma'am, minimum number of neighbors that should be there in epsilon radius.
Okay, or you can see within this like circle, minimum number of points that I need to take, because what is the minimum number of neighbors that I need to take? Depending on that, I will assign this data point as core point, border point, or the noise. So this thing we need to mention, that what is the minimum number of points that should come within this circle. Okay, so like you are having doubt over here that what is the core point, border point, and the noise. So this thing also, I think I had told you already that what is the density now, because this algorithm is based on density. So density means the number of points that are coming within the circle. Like if you are taking a data point and you are drawing a circle with radius epsilon, then other data point, number of data points that are coming within this, that is the density over here. Okay, like over here, if there are suppose 6 data points, you can say the density is 6, right? Now what is a core point? Now again, same thing. Suppose you have already specified that your epsilon is something, suppose you are saying 0.5. You want to draw a circle with radius 0.5. And what is the minimum point? Suppose that minimum point is 4. Now, Himanish, I'm taking one data point. I'm drawing a circle. The radius of that should be 0.45, 0.5. So suppose that is your circle with epsilon radius. Okay. Now count the number of points that are coming within this. Sorry. Suppose the number of points that are coming within this, that means the number of neighbors to this are 1, 2, 3, 4. Suppose I'm saying this one. Okay, you have to count this data point also. So 1, 2, 3, 4, 5, 6. So number of minimum point, number of points that are coming within this circle, that is 6. And what is the minimum value that we had set? That is 4. Okay, so if the number of data points within this circle is 4 or more than 4, then this data point, that is called the core point. Is it clear? Next now, suppose now I'm taking one another.
core point मतलब जो point है, मतलब specify number. जैसे कोई भी point है, मतलब graph में कोई भी point है, मतलब meet कर रहा है.
हिमानिश, मैंने क्या बोला कि you take this data point. Now I need to find out whether this is your core point, border point, or noise point. Okay, so what I will do, I'll draw a circle with radius what? Epsilon, that is 0.5. Okay, suppose जब आपने ये circle,
इसकी value
हिमानिश,
epsilon की value है 0.5.
क्या लिखा हुआ है? What do you think? What is written over here?
0.5 मतलब value होगी उसकी EPS की.
मेरे को तो यही लग रहा है मनीष. क्या बात है, क्या प्रॉब्लम है आपको? आपको जस्ट एक क्वेश्चन पूछनी है या आपको डाउट भी क्लियर करना है हिमानिश? फाइन. So this example I had taken, so I think this is now cleared. Okay, next is the reachability. I need one more concept of reachability, means whether one point is reachable from other or not. Now, what's the meaning of reachable? Reachable means whether their density is same, density reachable or not. Okay, so there can be two types of points. One are like you can say directly density reachable. Another one is like you can say density reachable only. Density means indirectly density reachable. Okay, so there are two types of points. First, I'm taking the directly density reachable point. Okay. Now, again, the same thing. Suppose you have been given a data point y and epsilon is given to you. So by using this as a center, you are drawing a circle with radius epsilon. Now, other data points that are coming within this circle are these, all others, 1, 2, 3, 4, 5, 6, 7, and 8. Suppose I'm taking this x point, okay? Now, if all other data points are within this circle, then you can say all these data points are directly density reachable from y. That means they belong to the same density. Okay, like here I have taken one data point x that is green in color, that you can say I want to check whether this is directly density reachable from y or not. Yes, this is directly reachable from y. Why? Because this is coming within this circle. Or other way you can say, whenever you are finding the distance between these two, that would be lesser than epsilon, lesser than or equal to epsilon. Okay, now suppose I'm taking this data point, one data point I'm taking outside this circle. Now I want to check whether this point x now, x1, this is directly density reachable from y or not. No, this is not directly density reachable from y. Why? Because if you will find out the distance between these two, that would be greater than epsilon, because that is outside this circle. So this distance would be greater than this. So they are not directly density reachable. Okay, so one thing I need this one, that whether I need to check whether two data points are directly density reachable or not. This way you can find out. So this was like already, I think you must be knowing. Okay, this is a different one. This is you need to find out now. Suppose a data point y is given to you and another data point x I'm taking. I want to check whether x is now density reachable from y or not. Okay, so what I will do, firstly, I will take this y as a circle. I will draw a circle, y as a center, and I will draw a circle with radius what? With radius epsilon. Okay. Now you can check that x is not coming within the circle. So one thing is that x is not directly density reachable from y, but it can be indirectly density reachable. How can you find out that? So what I have done over here, suppose I'm taking another data point P3. Okay. Now this P3 is directly density reachable from y. Why? Because P3 is within this circle. You can see this thing, P3 is coming within this circle that I have drawn, fine. So P3 is directly density reachable from y. So what I have done now, I'm taking P3 as a center, and again, I will draw a circle. Now, obviously, all the data points that are coming within this circle, they will be directly density reachable from P3, this P3, okay? Like I'm taking one point P2 now. I'm taking one point P2. This is within this circle. Okay, now I can say P2 is directly density reachable from P3. Why? Because that is within this circle. Okay, now the third thing, what I'm doing now, I'm taking this P2 point and I'm drawing again one more circle. Now you can check that this point X, that is directly density reachable from P2. Why again? Because again, X is within this circle that you have drawn, taking P2 as a center. Okay, so X is directly density reachable from P2. Now what you can deduce from this, that X is this P2, like you can say, I want to check whether X is directly density reachable from Y or not. Okay, you want to check that X is density reachable from Y or not. Now you can say X is directly density reachable from P2. Next, I can say P2 is directly density reachable from P3. P3 is directly density reachable from Y. So indirectly, I can say X is directly density reachable from Y. So this is your indirect density reachability thing. Is it clear now? What's the meaning of this? So whenever, like now again, what this is showing, why I need to find out. If I can find out these points that are directly density reachable or that are indirectly density reachable, that means their density is same. So what's the meaning of the density? That means they belong to the same cluster. So over here, I can see that all the data points that I have drawn over here, they actually belong to the same cluster. Because all these points, you can say they are directly density reachable from P2. All these points are directly density reachable from P3, and all these are from Y. So actually they belong to the same cluster. Okay. Now, is it cleared? Yes, beta. Is it cleared? Please write down in chat box. Otherwise, I will move to the next slide. That is, I will take one example now. Yes, Gurpreet. Shivam, Radhika is there. Yes, Shivam, is it cleared? Shivani? Okay, so shall I take the example then? Fine. So I will take this example. This algorithm I will take after this example. So what is this? Okay, before this, I'll show you one thing. I'll show you one animation, fine. Like from there, you can find out this one. Let me run it again. Okay, you can see over here. So what this is doing, this in this animation, I'm taking any point over here. I'm finding all the points now that are directly density reachable or indirectly density reachable from this one. So you will draw a circle. Within that circle, whatever points you are having, they are directly density reachable. Then you are finding all other points that are indirectly density reachable. So you can see that these circles you can see. Okay, now here all these points are all these data points that are now red in color, that means they belong to the same cluster. Once this is done, you can see all other data points, they are not indirectly or directly density reachable from these points. Okay, so what this algorithm will do, it will find out one move point. Suppose it is taking this point now. Again, it will find out what are other points that are directly density reachable from this one. So all those points, they will belong to one cluster. Once that is done, when other data points are not coming within this cluster, again, it will take a new point. Okay, again, it will find out all the points that are directly density reachable. So this way, you can see that in this example, there are 4 clusters. One cluster is being represented by this red in color. Another one is like, I'll show you, that is green. Third one was blue. And fourth one is yellow in color. So all these are directly density reachable, the blue one, yellow, and all these are your noise. So even the Dbscan algorithm will find out these outliers. So these are outliers. Why these are outliers now? Because they don't belong to these 4 clusters. They are not directly or indirectly density reachable from these points. Is it clear? Okay, now I will take one example and we will find out that how to find these clustering part using the Dbscan. Okay, this example is there. I'm taking this data set, fine. And you have been given like 2 features are given, X and Y. And suppose I have said that the value of epsilon is 0.6 and the minimum number of points that I have to take is 4. So these values are being set, okay? Minimum, points, and epsilon. And this is the data set that I want to take, and I need to find out that what are the different clusters depending upon these values of X and Y, okay? So first of all, you need to suppose you are drawing any scatter plot over here. Okay, so that plot will come like this, suppose. Okay, I need to check that which point is 4 point, which point is border one and which are the outliers within this. And if you're having any co-point, any point is being assigned as the co-point, then I need to find out what are the other points that are directly density reachable from this, because they will belong to one cluster. Okay, if there is any point like this way that doesn't belong to any co-point, then that would be declared as an outlier. So all these things we need to check. So first of all, I'm taking, suppose the 1.12, I'm finding one point over here. Suppose you are having this point over here. This is 1, 2, okay? I need to check that what is the distance of this point from all other data points, because I need to check first whether this is a core point or not, okay? For that, I need to find out the distance of this from all other data points. So you can use the same Euclidean distance formula, find out the distance of all other points from this 1, 2. Like what is the distance of 1, 2 from 1, 2? It will be 0. Then find out the distance of 3, 4 from 1, 2. How to find out that? Again, the same thing. You are taking 3 minus 1 whole square, Euclidean distance you are finding, plus 4 minus 2 whole square. Okay. So it is coming out to be square root 2 plus 2. This is 4 plus 4, 8. So if you will find out the square root of 8, it will be 2.8. Like this way, you are finding the distance of all other data points from this 1, 2. It is coming out to be like this. Okay. Now, what is the minimum distance that we have set? What is the value of the epsilon? You can go to the previous slide and you can check that the value of epsilon is what? It was 0.6. It is 0.6. Okay. That means if I'm taking 1, 2 point, this point, and if I'm drawing a circle now, if I'm taking this as center and I want to draw a circle with radius 0.6, okay, what are the other data points that are coming within this? Okay, now you need to tell me, is it 3, 4 point within this circle? Yes, Muskan, can you tell me 3, 4 point would be within this circle or not?
नो मैम
Why?
मैम क्योंकि उसका डिस्टेंस 0.6 से ज्यादा है ना
Yes, क्योंकि 3, 4 का जो distance है from 1 to it is 2.8. So it is more than this. So it will be somewhere outside this. Okay. So to this one 2.54, no, it won't come. Even this won't come. This. But you can see this 0.53 distance that is lesser than 0.6. So 1.2 and 2.5. Okay, this point will come within this circle, and one more point, this point will come within this circle. Okay, so you can see that whenever you are taking this as the center and drawing a circle, then only 2 points are coming within this circle. What are those 2 points? 1.2, 2.5, and 1 and 2.5. Okay, and what is the minimum number of points that we had set? Minimum number of points that we had set was 4. Okay, now, but there, how many points are coming within this circle? Only 2 points. So you can say this is not the co-point. This is not the co-point. It may be border or outlier, but that would be defined later. Okay. So this I have done just for this data point 1, 2. Similarly, you have to do for all other data points. You have to do for 3, 4, 2.54. आपको हर एक data point के लिए क्या find out करना है? Distance find out करना है from all other data points. Then you need to find out what are the different data points that are coming within this circle of 3, 4 or 2.54. And accordingly, we will assign a particular point as a co-point or your border point. Okay. Suppose I have done everything for all other data points also. So you will be getting a table like this. Okay, so what this table is showing you, like if you will take 1, 2 as a center, then only these 2 points will come within the circle. If you are taking 3, 4 as a center, then only these 2 points will come within circle. If this one, then these 3 would be within this circle. Okay, and for this one, and this one, like you can say 1, 2, 3, 4 are there, and for this one also like this way. Okay, so this is a second step. Like you can say that for or first step only, that for each data point you are finding the distances of all other data points from that data point, and you are finding what are the neighboring points, fine. Now here, the minimum number of points that I have set was suppose 4. Okay. Now which data point is having the 4 neighbors within circle? If you are drawing that data point as a center, you can see this one is having 4, 1, 2, 3, 4. And this one is having 4. So 1, 2, 3, and 4. And even this one. So there are 3 data points that are actually having the 4 neighbors within the circle. So what these points would be, these points would be assigned as the core point. So this is my core point, this one is my core point, and this one is my core point. Okay. About all other points, I don't know right now that whether they are outliers or border point, that we will do later on. So you can see this is my core point, the first core point, this is second one, this is the third one. Okay. So I have to take, now the third step is like you will take one core point and you will assign that to any cluster. So I'm taking this data point and I'm saying this is my cluster 1. Okay, that means 2.5 and 4.5, this is my center, and there are 4 other data points that are coming within this circle. So all these 4 data points, 3, 4, 2.5, 3, 5, and 2.5, 4.5, actually, they will be assigned to this cluster 1. They will be assigned to one cluster. Then I'm taking another core point. Then again, I'm checking whether they are directly density reachable from each other or not. If they are not directly density reachable, then you will assign that to one more cluster. 1 minute. That is the second cluster. But here you can see that these 2 core points are having 1 point as common. What is the common point? That is 1, 2. So what's the meaning of that? Its meaning is that this 1, 2 is directly density reachable from this. And then you can say these points are actually indirectly density reachable from these points. Okay. Or in simple way, you can say you need to find out, is there any point common between these 4 points? Yes, 1, 2 is common. When they are having some common point, then you can assign them to the same cluster. So these 2 points are being assigned to cluster 2, and this one is being assigned to cluster 1 now. Any doubt so far? Then I will tell you that what to do about the other points. Yes.
रिकॉर्डिंग फॉर्मूला लगाना है, डिस्टेंस फॉर्मूला लगा के करना है, मतलब जैसे मतलब जो से हाईएस्ट वैल्यू माइनस लोएस्ट वैल्यू हो उसके निकाल करना है, जो सो आपने क्रैब शे।
हाँ ठीक है,
ये
हाँ वही करना
है, मतलब समझाओ।
हिमानिश, आप पिछली जो स्लाइड्स है ना वो ओपन करना। आई थिंक दिस इज द 4th or 5th टाइम दैट आई एम टेलिंग यू द फॉर्मूला ऑफ द एडिट डिस्टेंस। ओके ओके, यस बेटा, ऑल
की हुई ग्रुप में।
ओके, यस बेटा, अगुन, इज इट क्लियर? अगुन, ओके okay, fine. So this is being assigned to cluster 1 and these 2 are being assigned to cluster 2. Now here you can see, I'm coming to this slide. This was my cluster. This was assigned to cluster 1 because this was the core point. Here I have written that is the core point. This was my core point. Okay, and this is the core point. Now these 2 belongs to cluster 2, so that is who's yellow in color, and this one that belongs to cluster 1, that is red in color. Okay, now I'm taking this point 1, 2. I want to check whether this is a core point first or not. No, this is not a core point. Why? Because the number of neighboring points are just 2, that is not 4. So this is not the core point. So next is I need to find out whether this is a border point or a noise. Now you can check over here, one of the neighbor of this is 1.2, 2.5. Okay, 1.2, 2.5. And what is that 1.2, 2.5? That is your core point. Okay, again I will do, suppose this is your 1.2, 2.5. This is your core point. And when you are taking 1, 2, if you are taking 1, 2, this one as a point, and drawing a circle, this is coming within this. Okay, so you can see within this 1, 2, there are not 4 points, they are just 2 points, but one of the point is your this one. Okay, that means this is the neighbor of a co-point. This point is a neighbor of this co-point. So I will assign that as a border point. Now you take 3, 4. Okay, there is 1 point, 2.8, 4.5. That means 3, 4 is a neighbor of this. And what is this? This is your core point. So this will also be a border point. Similarly, this one, this is a neighbor of this one. And what is this? This is a core point, the red one. So this is a border point. This is a border point because it is a neighbor of this one. Okay. But you take 1, 5. When you are taking 1, 5, there is no neighbor of that. Okay. So that will be your outlier. That is an outlier. Similarly, when you are taking 5, 6, there may be one, like in this data set, you don't have any neighbor. There may be one neighbor. Suppose here I'm taking 7, 8. There is one data point 7, 8. That is a neighbor of 5, 6. Okay, but this is not the neighbor of any co-point. 5, 6 is not the neighbor of any co-point. You can check over here. This is not the neighbor of any co-point. So you can say this is your outlier. 4, 3 is also an outlier. Why? Because this is not the neighbor of any other co-point. Okay, so this way you need to find out if any point like 3, 4 is the neighbor of this. So 3, 4 is an outlier. 2.5, 4.5. Okay, so this is the neighbor of 2.8, 4.5. So 2.48 and 4.5 is also a border point. So this way you will find out all the border points. Fine. Now the next step. Here you can see that 1, 2, that is the border point of this. So what's the meaning of this? That means this point is coming within the circle that you are drawing, taking this as a center. That means both of these are actually the density reachable. Okay, so if this is assigned to cluster 2, this will also be assigned to cluster 2. So this will be assigned to cluster 2. Similarly, you take this 3, 4 point. Okay, now this is a border point. That means this is within the circle when you are drawing a circle by taking 2.8 and 4.5 as the center. Okay, this is coming like you can see over here. 3, 4 is coming within that circle. So 3, 4 will be assigned to what? It will be assigned to cluster 1. 2.54, it will be assigned to cluster 1. This will be assigned to cluster 1, and even this will be assigned to cluster 1. So all these points are being assigned to cluster 1, and these points are being assigned to cluster 2. Okay, that are yellow in color. So this one, cluster 2, this is cluster 2, this belongs to cluster 2. So again, I'm moving to the next slide. So these are all your data points that are coming within cluster 1. These are cluster 2, and these are your outliers. So according to the Dbscan algorithm, for this data set, there are 2 clusters. Okay, and within those clusters, you are having all these points that belong to cluster 1. These points belong to cluster 2, and there are 3 outliers. That means Dbscan is also finding all the noise, like this can be your noise. These are your outliers that are being detected by your Dbscan. But if you're using k-means and hierarchical, they won't be able to find out these outliers or this noise. Fine. Any doubt in this example? Yes, you need to write down in chat box, beta. Is it cleared? Okay, Shivam. Next, this algorithm is whatever we have done. Okay, Pavan. So what it was the first step? You need to pick any point at random that has not been assigned to any cluster. Okay, or suppose that is not an outlier. So what we will do, we will compute its neighborhood to determine if it is a co-point or not. Like you can say over here, I'm taking any data point at random. Suppose I'm selecting 1, 2. I'm finding what are the different neighbors of that. Fine. And then I can assign, if it is a co-point, I'll say it is a co-point. If it is a border point, then I need to assign that to a border point. But suppose if that is a co-point, then I can say that that belongs to cluster 1, and all other data points that are directly or indirectly densely reachable from that co-point, all those data points will be assigned to cluster 1. Okay. After assigning the cluster 1, there may be some other data points that are not assigned to any other cluster, any cluster. Like here you can see, I suppose pick this point. I pick this point, I'm finding all the points that are densely reachable from this. So you can have all these points. After this is done, next again I'm picking any data point at random, and again I'm finding all the directly densely reachable points. Okay, so this way it is going on actually. So similarly over here in the algorithm, the same thing is written. Compute its neighborhood to determine if it is a co-point. Suppose if it is a co-point, and if it is not assigned to any cluster, you will create a cluster. So that would be your cluster 1. Fine. And then recursively, you will find out all the densely reachable point. That means you will find out all the points that are, only 1 minute is remaining. Okay, I will take it again next. All the points that are directly densely reachable or indirectly densely reachable from this. So that thing you are finding. And when you are doing like this way, there may be some points that were outlier previously, but now they can be assigned to this particular cluster. If that is the case, then you will move that outlier to this cluster. Fine. So if an outlier is added, change that point status